Here are the answers for the section 14-1 homework. We're working on synthetic substitution. In question number 1, we're given a polynomial. Take a look at the terms. We have an x cubed, an x squared, an x, and a constant. It doesn't skip any terms. And it's important to realize when it does skip a term because you have to put in 0 as a placeholder with synthetic division. We want to evaluate p of 2 not by directly substituting 2 in place of x, but by using synthetic substitution. Write down the coefficients of the polynomial. 3 from the x cubed, negative 2 from the x squared, negative 1 from the x, and then negative 4 is the constant. Make a bracket that looks like this. This is the synthetic substitution bracket. Now to evaluate for p of 2, take whatever that number is that we want to input and write it on the left side of the bracket. The process of synthetic substitution involves bringing the first number down underneath and then multiplying that number by what's out front. 3 times 2 makes 6. Write that under the second number. Now add these together. That makes 4. Multiply 4 times 2, which makes 8, and write it under the negative 1. Now add these together. That's 7. Multiply 7 times the 2, making 14, and add these together, making 10. This very last number that you get is the value of function p when you substitute in a 2. Let's try number 3. It uses the same polynomial, so the coefficients that you write down are the same. 3 from the x cubed, negative 2 from the x squared, negative 1 from the x term, and then negative 4. And make the bracket. We want to figure out what p of negative 3 is, so negative 3 is the number we're substituting in. Now run through the process. Bring that first number straight down below. Then multiply, making negative 9. Now add these, negative 11. And then multiply, 33. Add these, that makes 32. Multiply, that's negative 96. And then add these, that's negative 100. This very last number is the answer we're looking for. Number 5, we want to evaluate q of 3, and here is polynomial q. Now it's got an x to the 4th, an x to the 3rd, an x squared, but no x term. It's almost like it has a plus 0x in that position. So when we list out the coefficients, we have to put in a 0. So there's a 2, a negative 3, a 1, a 0, and a 1. Then make the synthetic division bracket. And the number that we're going to substitute in is a 3. Now run through the process. Drop the 2 down, multiply 2 times 3, which is 6. Add these, which makes 3. Multiply 3 times 3 makes 9. Add these, which is 10. Multiply 10 times 3, which is 30. Add these, which is 30. Multiply 30 times 3, which is 90. And add these, which is 91. This very last number is our answer. Number 7 is still polynomial q. So let's write the same coefficients down. The 2, the negative 3, the 1, the 0, and the 1. This time we're going to substitute in the symbol I. Now let's run through the process. Drop the 2 down. 2 times I is 2i. When you add these together, that's adding a real number and an imaginary number. That makes negative 3 plus 2i. Now multiply that by the letter I. So negative 3 times I is negative 3i. And 2i times I is 2i squared. But I squared's a negative 1, so that makes negative 2. Now add these together. It's negative 3i minus 1. Then multiply that by the letter I that's out front. So negative 3i times I is negative 3i squared, but that makes a 3. Negative 1 times I makes negative I. Now we want to add these. Well, adding 0 is really easy. You just get the 3 minus I again. Now multiply. 3 times I is 3I. Negative I times I is negative I squared. That makes positive 1. And now we want to add these together. So we have 3I plus 2. And that last number is our answer. Number 9, we have a new polynomial, function f, and we want to evaluate f of 3. So list out the coefficients. 2 from the y to the 4th, then negative 5 from the y cubed, then a 5 from the y squared, then a negative 20, then a negative 12. Make sure that you're looking every time to make sure it doesn't skip over any terms where you'd have to put a 0 placeholder in. We're going to substitute in the number 3. So let's run through the process. 2, 6, 1, 3, 8, 24, 4, 12, 0. The last number is the answer. It happens to be a 0. Number 11 is function f again, so the same coefficients. A 2, a negative 5, a 5, a negative 20, and a negative 12. And we're going to substitute in a negative 2i. Drop the 2 down, then multiply. That's negative 4i. Now add the real number to the imaginary number. That's negative 5 minus 4i. Now multiply that to what's out front. So negative 5 times negative 2i is 10i. Negative 4i times negative 2i is positive 8i squared, which makes negative 8. Now add these together. This is 10i minus 3. And multiply that to what's out front. So 10i times negative 2i is negative 20i squared. But that makes 20. Negative 3 times negative 2i is positive 6i. When we add these, the negative 20 and positive 20 cancel. We just get 6i. Multiply that to what's out front. So 6i times negative 2i is negative 12i squared. But that's a positive 12. When you add these, it happens to make a 0. And that last number is our answer. Next, number 21, we have a function called p, and we're even given that p of 2 is 6. We're asked, what would that last number have to be? Let's use synthetic substitution. Write out the coefficients of function p. There was a 2 from the x cubed, then a negative 3, then a 3, and then negative m. Now make the bracket. Let's use this piece of information. P of 2 equals 6. That means that when you substitute 2, you get an answer in this last spot of 6. Let's run through the process. Drop the 2 down. 2 times 2 is 4. Add these. That makes 1. 1 times 2 is 2. Add these. That makes 5. 5 times 2 is 10. Add these, and it makes 6. So that means negative m add 10 equals to 6. Now we can solve this for m. Subtract 10 from both sides. We have negative m equals negative 4. Therefore, m is equal to 4.